sign-in link, and that's to capture attendance. It's not anything for you guys, it's just to get the department funding. And I'll give you a minute to do that. All right. So I think now's a good time to get started. Just so no one's in the wrong place, this is for Math 125. All right. So I'm going to get recording started. It does not record your names. So it's like completely anonymous. It's just recording the board when I write. Okay. Okay, so how this session is going to work is for the first 45 minutes to an hour, I'll be running through the material that this exam is going to cover, the newer material. During that time, you can ask questions, and I'll pause after every single question I do and wait for questions. And then after that time has passed, there's kind of a free period where anyone with a lingering question can ask me. So that looks like I have this homework problem from last week that I hated and I want to redo it. Or my teacher showed this example in class and I never understood. Okay, so first we're going to do generic or general content review. Okay, so let's move to a whiteboard. And I'm going to ask you to put in the chat a yes if you are interested in reviewing chain rule, and a no if not. Okay, so a resounding yes. All right, so can someone tell me what the main purpose of chain rule is? So the main reason that you might need to use it. You could type this or say it. Any ideas? Okay, someone says to find the derivative. That's good. Someone says if there's an exponent, yeah. In a way. Okay, so yeah, it's a form of derivation, and you only apply it, or you only need to apply it when you've got what we call a function within a function. So you can think of Russian nesting dolls, right? They have the big doll and then like a little doll inside it. So that's how our functions are set up. And those are the cases where we need to use chain rule. And if we don't use chain rule, we get the wrong answer. So I'm going to start off with the first stage of chain rule, which is deciding which one of these is the inner function and where is the outer function. That's how we set up our chain rule derivative solving. Okay, now bear with me because I write slow on a keypad. Okay, I'm going to give you 30 seconds to think about what the inner function and the outer function are. You don't have to type it in the chat. Just think about it. Okay. So did anyone get the inner function as 3x minus 7? Okay. Now, what about the outer function? Can someone give me what they got? Someone said, okay, I'm seeing the correct answer now. Yes. So the outer function is going to be x squared. And if you're not sure how we get there, you can basically say, I'm going to take the inner function and I'm going to replace it with a big X. All right. And then that becomes our x squared. All right, let's do another. And by the way, if someone's asked about where we can find this recording, basically I upload this after it gets processed to a folder, the Vol Study Center folder. From there, I email all the professors and say, hey, I uploaded the video. Then it's their job to tell you guys where to find the video. So the actual mechanics of it, I'm not sure if they just share the folder link itself or if they have to share you the link separately, but that's how it works. So you should get it by tonight, if your professors are quick with it. All right, let's do another one of these. So I have square root of x cubed minus 8. So again, I'll give you a little bit of time to think about the inner function and the outer function. Okay, so when I'm looking for an inner function, there's basically three easy rules. Is one, if it's under a root. Two, if it's in some exponent of some sort, like this. And three, if it's just in parentheses, you know? So like natural log of blah, blah, blah. And of course, these squiggles that I'm drawing here, they have to be complicated. So they can't just be an x. If they're x plus 1, that counts for chain rule. If they're 2x, that counts for chain rule. But if I just have an x here, we don't need chain rule. All right. Did anyone get x cubed minus 8 as your inner function? Okay, good. And for outer function, again, way we can think of this is we replace that inner function with a big X. So then our outer function is just that square root of X. All right. Let's just do one more. Okay. Whenever you're ready, type in the chat what the inner function is. Very good. 17x is your inner function. Again, we can look at these general rules, right? So it's inside parentheses and it's not just an x, it's something more complicated. Very good. Type the outer function, please. ln of x, yes. So make sure you don't just say this because we have to complete it. It has to have the x as well. So natural log of x. Very good. So how about we go about actually solving one? Let's start out with this guy over here, the 3x minus 7 all squared. So the first thing I want to do here is I want to take the derivative of the outer function and I want to ignore the inner function completely. So you can think of this as if you're going into this derivation scared and afraid of chain rule, and you don't know what to do with this complicated mess in the middle. So because it scares me, I want to ignore it. Okay? And that's what I'll do for the time being. So what rule do I use when I've got a power here? So I'm just looking at that squared sign. What rule do I use? Yeah, I think they sometimes call it like the simple rule, but I know it as the power rule. Good. So that's the one where you have your something squared and you bring your two down and subtract a one. All right, well, let's do that. So I have now the two in the front, and this is all raised to a one, which I don't need to include. And remember how I said I'm ignoring the complicated interior for now because it scares me? That means I'm not going to change it. I'm just going to write it in there and pretend it doesn't exist. Okay. So from here, from what I've just done, this is the wrong answer, okay? Or it is not correct. But the good news is that it's actually very close to the right answer. So how do I move from incorrect to fully correct? There's just one step I need to do. So after I've done what I've done here, I'm going to multiply by something. That something is going to be the derivative of the interior function. Okay. So what's our interior function again? You can type it or say it if you're brave. 3x minus 7. Good. Okay, so what's the derivative of that? That's just going to be a 3. So we're going to multiply our not quite correct answer by 3. And now we can simplify. 6. So I did 2 times 3. 6, 3x minus 7. And yeah, I can multiply through if I want. It's not mandatory or anything like that. So that is our derivative. Okay. Questions on that? Again, you can unmute yourself if that's faster. Okay, someone asked a question, but they didn't finish it. Or maybe I'm misunderstanding. The person who said that, do you want to like unmute yourself and just ask me? Or I can wait for you to retype it. Yes. Okay. Okay, yes. So what this person's asking in the chat is they're saying, well, we started with x squared and that became 2x. But then for some reason that whole x like seems to have disappeared. So the reason it feels like something is missing is because when we're talking about this outer function here, um, we're looking at the outer function, and then this is what gets plugged into it in reality. Okay. So another way to say that is we're not simply derivating x squared. We're derivating the inner function squared. Because of that, there is no simple x in our real equation. For the sake of the chain rule, we treat it as if it were an x, which is why we can bring this power rule down like this. But you see how our x is really that whole chunk, that 3x minus 7? So essentially, to make this problem more understandable for us so we can solve it, we treat that whole 3x minus 7 as the x, as the interior. But really, it's like a chunk that belongs together. That's why we don't see an actual x in here. It's because there is no single simple x. There's rather a mess of 3x minus 7. Okay. I hope that helps. Do you have any other questions, anyone? Yeah, so someone's trying to say it in a different way. That's good. So, yeah, they said basically g replaces the x. Yeah, so if you want to call your inner function g and call your outer function f, then yes, because they say that chain rules for f of g of x. So, yeah. So when we're doing x squared, we're really looking at that something squared. And in this case, that's the g, which is 3x minus 7. Okay. Thanks for saying it in the other way, whoever said that. Right. Anyone else before we move on to another chain rule problem? Okay. How about we do this natural log problem? So remember, our first step is to ignore the interior and to just try and do the derivative as if there was no complication. So can someone tell me if we just had ln of x, like that, the outer function, what's the derivative of that?
Wouldn't that be 1 over x?
1 over x. Very good. Okay. So if that's the derivative of the external function, and if I want to ignore the interior because it scares me, I'm just going to say, well, let's derivate. I'm going to take that interior goop and I'm going to put it under 1. Okay. So again, what I just did, I'm not at the answer. This is incorrect. But to get to the answer, it's just a little hop away. So I'm going to multiply by the derivative of the interior function. Our derivative of the interior function is 17. And now if I do this like this, I can see I need to simplify. And I get 1 over x. Now, let's actually do a more complicated one. And I want to do natural log of 17x plus x cubed. Okay, well, there's a longer, more complicated interior function now, right? So our interior is going to be 17x plus x cubed. And the external function is natural log of x. So first step here, we ignore the complexities of the interior function, and we just follow the rules for how to derive the external, which is put it under a 1. So I'm going to take this whole mess, 17x plus x cubed, and I'm going to toss it underneath a 1. Can someone tell me the final step? What do I multiply this by to finish the chain rule process?
The derivative of the inside.
The derivative of the inside. Yeah, perfect. So can someone tell me the derivative of this interior function here? Good. 17 plus 3x squared. Now I want to highlight this, so I'm doing it in a different color. When you're multiplying that derivative of the interior, please put parentheses, okay? Otherwise, your order of operations is all messed up. All right, so we can rewrite this if we feel like it and just call it 17 plus 3x squared all over 17x plus x cubed. Nice. Okay. All right. Questions on chain rule before we move on? Okay, looks like we've got a lot more participants. So I'm gonna do another plug for that attendance link. This link is going to ask you like, what class are you here for and stuff like this. So go in there and sign in. It's not for you to track if you showed up. It's just to get funding for the department. So we really appreciate it if you sign in. Okay. Now, since we have so many people here, I think it's worth asking. Usually I end up skipping power and quotient rule, or at least power, or my bad. Usually I end up skipping product rule because people tend to want to skip it. But if you want to go over product rule, you can put that in the chat or you can directly message me and then I'll go over it. So I'm going to give you like a moment. Just doing a survey here. Okay. We're seeing a few people who'd like to do product rule. So let's do that. Okay. What do I want to make this? Okay, let's call it xe to the x. This will be our first product rule problem. Now, the reason we have to use product rule here is because there's two terms that include x. Okay? Two terms that include x. If I were given 3x, I could divide it into two terms, couldn't I? But it wouldn't be useful to do product rule here because this term does not have an x in it. So we don't need to use product rule. We can simply say, well, power rule, sorry, this is raised to the first power, bring that down. And then the x becomes x to the 0 times 3 times 1. And if we have x raised to the 0, that just becomes 3 times 1, which is 3. I know I sped through that. That's because it's more theory. You don't need to know that. That wasn't product rule necessarily. That was just showing what happens if you try to apply product rule in a place where it doesn't need it. And if you try to apply product rule in a place you don't need it, you get the right answer. It just wastes your time. So don't sweat it if you apply it in the wrong place, but time is precious. Okay, so we've got what people like to call function f and function g multiplied together. Function f is x. We also want to find f prime, which is going to be 1. Then we have g, which is e to the x. and G prime. Can someone tell me what G prime is? So when we have an e to the x, we actually don't change that. So it remains e to the x. Very good. All right, now here's our little formula. We have f prime g plus g prime times f. For the record, you can switch that order. It doesn't matter. Just like 3 plus 5 is the same as 5 plus 3, right? We can change the order of the things we add, and the answer will be the same. So let's go ahead and plug in things, okay? First of all, I have f prime times g. Now I have my addition sign, and now I've got g prime times f. Someone asked if this reporting is going to be posted anywhere. Yes, it will. And when I post it, I'm going to email your professors saying it's been posted, and then they're supposed to get that message to you. Okay. So let's go ahead and simplify really quickly. We should get e to the x plus x e to the x. Questions on that? Okay. Let's try one that also includes, and this is a spoiler, also includes chain rule. Okay. Let me think. Okay. What do I want to do? That's what, okay. Sorry, guys. I make these up on the spot. All right. So we've got here's what we've got. Now, when I look at this, I should have my gears turning and I should say, I think there's two terms multiplied together here. So I'm going to go in and check. Okay, I've got an x and I've got a natural log of something with an x in it. So since these both have an x in them, I think I'm good to go and use product rule here. And then I also do a check and say, do I need chain rule? Can someone tell me if I need chain rule here? Yes or no? Okay, good. Yes, we do need chain rule here. Specifically, we need it for that second function, which we're going to call g. So just like before, let's write our f and g out nice and tidily here. You don't always have to do this, but when chain rule and product rule and quotient rule problems get long, organization is your best friend. Because even if the math is easy, like, okay, 3 times 5 and x times x, if your organization is messed up, you might make silly mistakes that just ruin your score. So some people, and most people, I'd say, really benefit from organization. I've gone ahead and done the derivative of our x there. Now you're going to see we have a more complicated little thing coming up here, which is g prime. So let's talk about that. G prime is where we use chain rule. What's the inner function for G prime? Can someone tell me?
Is it inner function just 3?
Can you say that again?
Is the inner function just 3?
Inner function is going to be what's in the parentheses.
Yeah, would that be 3?
We're going to include the whole chunk within the parentheses. So 3x
Oh, okay,
minus
okay, okay, okay.
You kind of took the derivative of the interior
Oh, you're
function.
talking about derivative. I thought you were just asking. Oh, I thought you were asking
Yeah.
derivative of an inner function. I know you're asking just inner function.
Yeah. Okay,
So
got
the
it.
inner function itself is just 3x minus 1.
Yeah, we're taking it step by step here. Good.
Okay.
So 3x minus 1. Outer function is going to be natural log of x. Okay, someone's asking, why can't we, okay, well, you can read in the chat, but I'll read it out loud for people in the recording. So someone's asking, why can't we use the rule where if you've got ln u of x, you just say that derivative is going to be 1 over u to the x times u prime of x. And I am delighted to point out to you that that is actually chain rule. So that is exactly what we're doing. This is just a specific rewriting of chain rule for natural log. But yeah, that is exactly what we're going to do. And it's going to work out just like that. So I'm glad you know that rule. Someone here is asking, how do we know to use chain rule here? And instead of just doing it straight up. And the reason we do chain rule is because the stuff in the parentheses here, this 3x minus 1, is complicated. By complicated, I mean it's not just x. So anything that's not just x within parentheses or tiny, tiny in an exponent, suddenly we need to use chain rule, okay? So even if this were like x plus 2, you
Two
still want to
different
use
times.
chain rule. Oh, is someone talking? Okay, never mind. I think they just had uh, a microphone mistake. Okay. Any more questions? I hope that clarifies. Okay, so back to it. We were finding G prime. And just like this person said over here, you can think of it like taking that inner bit, tossing it under the 1, and then multiplying the whole thing by its derivative. So we have our outer function is natural log of x. And the derivative of natural log of x is you take that x and you put it under 1. But here, our x is this whole chunk, this 3x minus 1. So let's follow our rules and say 1 over 3x minus 1. And we finish multiplying off by what you were saying earlier, Mr. Only Person with your camera on. And you're going to multiply by 3, which comes from the derivative of that interior function. So that's actually going to be 3 over 3x minus 1 as g prime. Good. So let's put it all together now. Remember, we had f prime g plus g prime of f. Now it's just to plug in free for all. So f prime is 1. G is natural log 3x minus 1. Let's put plus now g prime. And we want to multiply that by our f, which is just going to be x. So I'm going to put that right here. And there you have it. So that's going to be your answer for this product and chain rule combination problem. So pausing for questions again. Okay, someone here is asking about simplification. I'll just answer them directly. So I think they're trying to say that they want to like cross out the 3's or something. Is that correct? The person who asked that, is that what you mean? Okay. Yeah, so the reason we can't do that is because if we wanted to do that, we can't just take out the 3 from this term. We would also have to take out a 3 from this term, right? Because we have to be fair. We have to take out a 3 from every single part. So if I wanted to do that, I'd have to say 3x over 3x minus, and then by removing that 3 from here, it'd be 1/3. Now I can go ahead and cross out the 3. But now my fraction looks dumb because I have a mini fraction in the denominator. So yeah, you can't just cross out coefficients like this because since there's that negative sign there, that subtraction sign. So that ruins our plans. All right. Okay. What do we do next? Let's talk about natural log expansion. All right. Move over here. So natural log expansion is a really handy tool for derivating intimidating looking natural logs. So here we've got, for example, natural log of 3x minus 1 over 8x. I could use chain rule, couldn't I? I've got something complicated, something that's not a simple x, inside of another function. But if I did chain rule, it would be a real pain, okay? So there's an easier way to do this. And I'm going to utilize or leverage one of these two rules. So let me write them out for us. First rule is that if I have the natural log of an a multiplied by a b, I can split that up as natural log of a plus natural log of b. Now, hold on one second. I'm thinking there's an issue with people not being able to see the whiteboard. So I'm going to close the whiteboard and rejoin. All right. Ah, that looks better. Okay. Okay, now the other rule that we're looking at is if there's natural log. Oh, very good. Now it's not letting me write. Okay. Natural log of a over b, we are allowed to expand that out into natural log of a minus natural log of b. Now, just to clarify, these two rules are not derivative rules. They're just rules for reformatting or rewriting things. So not derivative rules. But let's see, how can we leverage one of those to make our life easier when we derivate? So actually, I want to use this bottom rule here, and I'm going to rewrite this complicated function that I have up top. So I'm going to say natural log of that top piece minus natural log of the bottom piece. All right. And we've already previously done chain rule solving for natural logs similar to these, no? So to finish this problem off, we would just take the chain rule derivative of this guy, do subtraction, and then chain rule derivative of this guy. Voila, our answer. And we don't have to worry about the other complicated methods we'd have to slog through if we didn't use this rule here. So that's what's cool about natural log expansion. Okay, let's just do one down here. Okay. So I'm going to give you a few minutes to take paper or just your brain and try and solve this one. All right. And I mean solve it through. So not just set it up like how we have up here. You might not finish in the time I give you, but at least you'll have your thinking hat on. Can't believe I just said that. And then I'll walk you through it. All right. Hopefully you've at least set it up and you'll be able to follow along. So when I see this problem, I think, wow, that interior looks really unwieldy. Okay, so I'd like to use one of these two rules here to break it up into more bite-sized pieces. And since it's a multiplication situation with an A and a B, I'm going to break it up like so. So natural log of A, that first bit, plus natural log of that next bit, the B. Okay. Now we can do the derivative, but there's one thing I want to point out, which is there's a list of rules involving the interaction between natural log and E. And it's nice to have those memorized because if you do, you would know that we can rewrite that first bit just as X. And then we can go on and say natural log of 40X. Okay, now let's derive. So derivative of X is just 1 plus, okay. So here, can someone say yes if we need chain rule and no if we don't?
Yes, we do need a chain rule.
Yes, we do need chain rule. Very good. So we need chain rule here because in those parentheses, it's not just a plain old X, but rather it's a 40X. So now we've got an extra layer of complexity that we need chain rule to deal with. So first things first is we just use the rule for the natural log, and we're going to ignore that complexity temporarily and just tack that 40X on the bottom like there's nothing wrong. But now we have to add in the complexity by doing our final step, which is to multiply by, okay, can someone type in the chat what we multiply by? Good. So we're going to take the derivative of that interior, which is 40, and we'll multiply the whole situation by 40. Then these 40s cross themselves out. And our final derivative answer is going to be 1 plus 1 over x. All right. Any questions on this before we move on to the next topic? Okay, so I think people would like more elaboration on the rules with like E and X and L and X together. Um, okay, so this, let me do a different color. Ooh, someone says, can you solve the problem all the way through? Okay. To the person who said, can you solve the problem all the way through? Can you clarify that? Because I do want to say, if you're talking about this, we can't simplify that anymore. So, okay, sure. So let's just talk about the interaction rules real quick, and then we're going to revisit this problem up here and solve it all the way through. Cool. So one of the rules is that if you have natural log of something to an exponent that is equal to bringing that exponent down like so. So now it's multiplied. Again, that's not a derivative rule, that's just a rewriting rule. Then we've got the one I mentioned up there, which is that if you have natural log of e to the x, or I should really be writing equal signs here. That's just x. And now comes the embarrassing part where I Google to make sure I'm not making up these next rules because it's been a while. Okay. Okay, so I was right. The last one that I wanted to say was if you have e raised to the natural log of x, that is equal to x. Okay. You can write these down. I would recommend it. And if you forget, you can just do what I just did, which is I typed in natural log x e rules into my phone and it gave me little PowerPoint slides and yeah, easy way to jog your memory. So let's go back up here and as requested, we're going to solve this problem fully. So I'd like to actually bring it over here if I can. Good. So I'm going to do this the same way as I did the other. Basically, I'm going to solve them part by part. So first I'll solve this guy, then I'll put the minus, and then I'll solve this guy. Do I need to use chain rule for this first one? Type yes or no. So since it's not a simple x, good. Since it's not just one x in there, I do need chain rule. Do I need chain rule for this? So this is also chain rule because in here, okay, it's not just an x, it's an 8x. So if it were just natural log of x, we wouldn't need chain rule. But since there's that extra 8 in there, it adds a little dusting of complexity, and now it's our chain rule problem. Let's get into it. So for our derivative, we know that natural log of x is derived as 1 over x. So I'm going to do my first step for this first term by throwing it under a 1. If it were just an x, that would be sufficient, but we need chain rule. So we're going to multiply by 3, which is, I get that 3 from taking the derivative of that guy. Now I'm going to put the subtraction sign and head on to the next term. Again, I'm going to throw that under the 1 because I'm following this pattern up here of derivating a natural log. Now, what do I multiply this last term by to finish chain rule for it? 8. Wonderful. Now let's go and simplify. So we've got 3 over 3x minus 1 minus, these 8's cancel, very convenient, minus 1 over x. Now it's question time. Anyone? Okay, we've only got one more topic before we move into the free question zone. That's not to say that I've covered every minutiae of every single thing that will be on the exam, but I've covered most general topics. Okay, so let's go. We're going to talk about dropping things off buildings. Yay. Okay, let me do my little drawing. Here's my beautiful skyscraper. Let's give them big doors. All right. Now, I'm going to say that this skyscraper is 2,180 feet tall because I said so. And I'm going to be dropping a penny off it. Okay. So I'm going to start my penny here, and it's going to go all the way down. So I think usually they're going to give you the equation. So we're going to call this the position function for my penny. S of t, with t being time in seconds. So it's going to be negative 16 t squared plus this mysterious term, which I'll talk about later, plus the height of the building, 2,180 feet. Okay, so what's this term? This term is only for if the initial velocity, so the speed at time 0, is not 0. That's not the case in most of the problems you guys deal with. But in theory, what that would look like is if either I'm standing at the top of that building and I kind of toss the penny up so it flies up for maybe half a second before it flies down. Or alternatively, I kind of chuck it downwards as fast as I can. In either scenario, it's not velocity 0 at the beginning because I'm giving it more momentum up or down. But in this case, I'm just simply releasing. So V0 is 0, and that mysterious term disappears. So that's pretty convenient. So anyways, our actual position function here is going to be 16t squared plus 2,180. Now, what if I want to find distance fallen after 1 second? Actually, I'm going to say 2 seconds. How would I approach that? Can someone type that out or unmute themselves? How would I go about finding this number? Okay, good. Someone said plug the 2 in for the t. Nice. So I'm going to take S of 2 and solve. Negative 16 2 squared plus 2,180. So that's going to be 4 times 16. That's 40. Oh, wow. Brain freeze, guys. 64, negative 64 plus 2180, which I think is going to be 2116 feet. Now, did I answer my question? No. Okay, good. So this is not my answer. Don't go circling this. Why is it not my answer? Um, why is it not my answer? Well, it's not my answer because I didn't ask how far is my penny up from the ground. I asked how far has it fallen? So I'm actually looking for this distance. So to find the answer, I'm just going to say, what's the difference between this number and this number? Okay, that's going to be 64 feet. So my real answer is I've fallen, or my penny, it's not me, my penny has fallen 64 feet in those 2 seconds. To the person who asked if we're getting the equation on the exam, do you mean this equation? Okay, I'm like 90% sure. I don't remember seeing in any of the review materials that I've been sent any problem where you had to construct this yourself. I could be wrong, but I'm pretty sure that they're just going to provide it for you, okay? Okay. Here's my next question. When does the penny hit the ground? Now, this is a little bit more of a complicated question because I have to find something or find 2 things to get to my answer. So the first thing I need to do here is I need to ask myself, how do I know when the penny hits the ground? How do I know? Well, some people might say, well, I know because the penny has fallen this many feet. Okay. So they might say when the position is 0 feet off the ground, then the penny has hit the ground. So yes, this is the time it takes to hit the ground. So we're looking for t. Cool. So let's do that. Let's say we're going to say s of t is equal to 0. And let's solve. So s of t was negative 16t squared plus 2180. Okay, so now I'm going to need to pull out my calculator, but I'm going to put that negative 16 over here. Now, 2180 divided by 16. Let me do that really quickly. 2180 divided by 16. Good. So I get t squared equals 136.25. And now I need to find the square root of that. Okay. My calculator is telling me lies. It's telling me that's the square root of that big number there is 3. So that's not right. That's more like it. Okay, so we should get 11.67 seconds is the time it takes us to watch the penny fall from the top to the very bottom of the building. Can someone tell me why I didn't put a plus or minus sign here? Because I did have that square, right? And then I took the square root of this guy. Why didn't I follow my own rule and say plus or minus? Good. So mathematically speaking, yes, we can say plus or minus, but have you ever heard of negative time? Because I haven't. So that's why our answer is positive 11.67 seconds. Okay. Any questions on that so far? All right, let's do one more part to this. And let's find out velocity when penny hits the ground. Okay. So to solve for this, someone asked me a question in the chat. So let me see. Okay, let me read through these real quick. Hold on. Okay, so someone's asking how we got from here to here. So they're saying like, what's this step? So basically we're just dividing both sides by 16. So dividing both sides by 16 removes this 16 here. And then to this 2180, I'm going to divide that by 16 as well. That's where I get this kind of fractional number down there. Now, someone's asking if we can just divide 64 feet by 32.
No,
Wait, no, that's
right, the total.
That's not what they meant.
Right.
You're saying this is 2180.
Yeah, 2180 by 32, right?
Yeah, okay, yeah. Okay, so someone's asking, can't we just divide the 2180 by 32 feet per second? Okay, well, let's see what happens. All right, so we get 2180 divided by 32. Okay, let's see if I type that in right. I need to be careful. 2180 divided by 32. You're going to get 68.125. Can you try that yourself? See if you get the same thing. Did anyone else get that number?
Calculator on my phone is not doing this correctly with Zoom open.
So can someone else confirm? Okay, yeah. So this is what you get if you just divide directly like that. And as we can see, that does not give us the seconds that we need. Okay, I think. Yeah, the actual reasoning. Okay, someone's asking why would you need to divide by 32? So you don't actually need to divide by 32. What the person who was asking that question took the 32 from is if you go up here and you want to find S prime, also known as velocity, you're going to use power rule to get negative 32 t. So they were looking at this 32 here and thinking, why don't we try dividing this height of the building by 32, and maybe we'll get the time it takes from the top to the bottom of the building. So that's where they got their 32. But just to clarify, as we see here, we don't get the right answer if we divide by 32. So that is not the time it took
Right, because
to
there's
hit the
no
bottom.
if you do it that way, there's no acceleration. I don't know what I was thinking. It's
You're good. You're good. Yeah. So what he just said is like basically by dividing by 32, he was kind of ignoring this element, which is the t, because that t changes over time, which is why we can't simplify it so nicely and divide by 32. It's fine. It's fine. Easy misunderstanding. You're good. All right. So let's just erase that little, clean our workspace here. How do I find the velocity when the penny hits the ground? It's not so bad. I am just going to take that little velocity function here, which is negative 32t. And I'm going to replace that t with my 11.67. Okay, calculator, please. 32 times 11.67. So I'm going to get negative 373.44. That is in the unit feet per second. Because velocity is really just speed with a specific direction. So speed, except you can call it negative or positive. Now, just to point out, this is negative, okay? Can someone tell me why the velocity is negative here? So the velocity is negative because I just said velocity has direction, right? In this case, the object is falling. Good. So that means we're moving negative. Now, that means that we have to answer for the correct answer. We need to say the velocity is negative 373.44. If I answered positive, that would mean my penny is just flying sky high, and that is the wrong answer. So be careful with your sign. Now, what if the test question was, at what rate is the penny falling when it hits the ground? Can someone tell me what my answer would be there if that was the test question? It's kind of a tricky one. It's in the details.
Are you
So,
saying is that is it expression is the rate? Because if so, then I think it is. Like, is that
um, so what I'm trying to like point out here is that the velocity is directional. That's the main takeaway I'm trying to drive home. When they say what rate is it hitting the ground at, we know we're having this downward force, which means this negative. In this question I've crafted here, I say falling. That implies that it's downwards, a negative. So because of that, we actually answer in the positive. It's falling at a rate of this. So to restate that again, the reason I answer positive here is because the falling represents the negative here. Now, hopefully your professors won't try and trip you up like that, but I know that they did. So just something to keep in mind is read carefully. Any questions on that? Because we're about to go into the free-for-all.
so to make sure I have that right, the velocity is negative, and the rate
Yes.
is still the velocity, just as a positive integer. Is that
It's all in the wording. So if I said, at what rate is the penny's position changing? Do you see how I haven't implied the negativity already? In this case, it would also be a negative answer because I didn't already express that I know it's negative.
I understand and hate that. Thank you.
Yeah. Well, hopefully they don't do you like that, okay? I just can't be sure, so I pointed out. Okay, anyone else? Oh, someone said, where did the negative 32t come from for the velocity question? Great question. So they're asking about this. How do we just decide to multiply that with our t? So that comes from up here. Position function, velocity function. Velocity is the derivative of position. And we used power rule over here. And we got negative 32t for our velocity function. Just for anyone who's curious, this negative 16, that's what we call the gravity constant. So that is the acceleration that gravity on Earth is exerting on all of us and every object. In meters, I think it's negative 9.8 meters. But that's the reason that whenever you get these problems, there's always a negative 16 or negative 9.8 if it's in meters. So that's just a physics thing. It's not a number pulled out of nowhere. All right. Oh, this looks pretty. Okay, so we're moving into the general question time. So if you're feeling satisfied, you're welcome to leave. But if you've got some nagging question, now's the time to ask and I'll walk you through it.
I might just borrow one of
Everyone
yours,
can
because,
benefit.
like, I don't care how I look.
Okay. Okay, so someone wants to do differentiation practice. Someone wants to do problem with an e to an exponent. Okay, yeah. To the person who wants to do differentiation practice, can you specify one type? Like, do you care? Okay. Got it. All right, let's cover some e with an exponent stuff. First of all, can someone tell me if I just have e to a boring old x, how does that get derivated? E, do I change it? E to the x. Yay, okay. So when it's just a simple x, don't change it at all, okay? That's sometimes what bothers people so much about e to the x, because it feels weird to derivate when your answer is the same as the question. But that's how it is. What you do not do, writing it in red, you do not apply power rule. This is super wrong, okay? So don't go trying to, carry the x down and subtract a 1. I know it feels comfortable because that's how you started off when you were first learning this stuff. It doesn't work, and I'll show you why. When you have x to the third or something, you can use power rule. Notice how the x is in the base? Well, with e to the x is not in the base. So we can't just treat these in the same way because they're different. So that's why we can never use our power rule here. So now that we know e to the x derivates to e to the x. Okay, someone wants to know the difference between, okay, we'll get to that later. So let's make it more complicated, okay? I've got 3e to the 7x. Okay. Do I need chain rule? I do need chain rule. Because in this exponent, I don't just have x, rather I have 7x. So, and we remember that if there's a constant multiplied in the front, also known as a coefficient, we don't have to worry about it. That's just going to be multiplied by whatever our derivative is. It just hangs out in front and chills. So what are we going to do about this e to the 7x? Well, you remember how the first step was to just derivate according to the external function, which is e to the x? We're going to derivate according to e to the x, which is this rule. And we're going to ignore the interior function. So that just means I'm going to write e to the 7x. I don't like the 7x. It's complicated, so I just ignored it for the time being. Now, to finish up, I need to multiply to finish my chain rule. What do I multiply by? Not 7x. Actually, I'm going to take this interior function. I'm going to find the derivative and multiply by that. So I'll just multiply by 7. Now from that, we get 21 e to the 7x. And that's it.
For that one,
Let me
can we technically like bring down do 3 times 7 e to the 7x like without doing it like similar to what you did but put the 7 in the front, kind of like the power rule?
Okay, so let's think about that. Why do you bring the 7 down?
I was just thinking of it in terms of the power rule.
Yes, so it's not the power rule, but if you're thinking visually, you're thinking like visually, this is basically what we did, right?
Yeah.
Okay, so yeah, the reason it looks so nice and clean here is because 7x is super easy to derivate because the x just vanishes. But let me ask you, if I had e to the x cubed,
Oh, we'd have to do 7x.
it's not as nice, right? I can't just bring my 3 down because it's visually clean, but it doesn't work.
Yeah.
You see?
Okay. Okay, yeah.
Yeah. If it's literally just a coefficient like 8x, that's gonna end up being what you do, like visually. But
I was gonna end up that way.
once that gets more complicated, you can't do it. So I wouldn't use it as a blanket rule.
Okay.
Yeah. Okay.
Real quick, I gotta go,
does
but thank you for this session. It was very
Oh
helpful.
yeah. Okay, thanks. Bye. Does anyone want to go over another of these problems before we answer someone else's question? Okay, let's do another. Cool. All right, let's go over here. Someone says they want to do fractions and square roots too. Okay. I hope you guys don't mind if I go a little crazy here. This one's a busy one. Okay, this is busy. This is a lot. So, what do we see here? Do we see chain rule? Yes, there's chain rule. This is complicated and I don't like it. Okay. We clearly need chain rule because in the exponent, there's a lot of mess. Okay. Now, when we derive, remember, my first step is to derivate the e to the x or e to the something as if there were no complexity. So I'm just going to do e to the blah, blah, blah. Okay, so I've sidestepped my fears for now. But now I have to face them, right? I have to multiply by something to finish my chain rule process. I'm multiplying by the derivative of this dude. So let's go to the side and figure out what this guy is, okay? I have square root of x cubed minus 1. What rule do I need here? Or I should say, what rules do I need here to solve? I need the power rule, right? Because I can rewrite this, can't I? I can call it x cubed minus 1. We wouldn't say quotient rule because that's when we're dealing with fractions. Now, what's the other rule I need here? Chain rule. Good. Because I've got something in parentheses that's not just an x, it's a whole mess. So I need chain rule. Very good. So let's go ahead and derive this. Or derivate it. My bad. All right, so first I'm going to use chain rule. Or, hello. First I'm going to use power rule and just ignore the inner function, which is just all this goop here. I subtract 1 from my power to get negative 1/2. Now, I multiply the whole thing by the derivative of the interior. Can someone tell me what the derivative here is? So we're going to look at this inner function, and we're going to say, let's bring that 3 down and subtract 1. And of course, this minus 1 disappears because it's a constant. So if we simplify that, we get 3x squared over 2 times x cubed minus 1 to the negative 1/2. We could rewrite that if we wanted, not super important. So let's zoom out a little. I want to show you the big picture of what we've been doing so far. We're trying to apply chain rule here. But in order to do that, we had to apply chain rule again. And let's see why that makes sense. Well, if we zoom into this guy, this function here, we've got e to the complicated thing. And inside that complicated thing is another complicated thing. So we've got function within a function within a function. So double chain rule, okay? A little bit messy. So let's zoom back out. The whole point of this over here was just to find the derivative of the exponent. So now we can just plug it in, right? Let's say we've got e to the x cubed minus 1 times 3x squared over 2 times x cubed minus 1 to the negative 1/2. I'm not going to try and rewrite that more prettily because we've only got 6 minutes left. But any questions on that whole thing? All right. Other questions that people want solved? Yeah, you're welcome. Does anyone want to do quotient rule? E, okay, so someone wants E and quotient rule like merged together. Let's do that, yeah, good. I want a different color. Okay, to the person who just asked if we can do power rule for most quotient rule problems, the answer is yes. Okay, and if people want to know what they mean by that, they're just saying like, hey, if I've got like x minus 1 over x plus 2, can't I just rewrite that and call it x minus 1 times x plus 2 to the negative first power? Because then I can use product rule, right? Two terms. You absolutely can. You just would have to use chain rule as well. So it's just down to personal preference. I wouldn't say either is necessarily easier or harder. It's just vibes, okay? It's your choice. Okay. So let's invent a quotient rule and E problem. Okay. Here's my problem. First of all, can I simplify this before I derivate anything? I'll give you a second to investigate. Can I simplify? Beautiful. Someone just told me that this simplifies into x. Good. So we mentioned these rules earlier, but yes, this is like so. Now I'm going to try and write faster, but we're running out of time. We might run over. So we can say we've got the high function and the low function. I call them H and L. We're also going to need to know what H prime is and what L prime is. L prime is pretty straightforward, right? We use power rule. Can someone tell me L prime? Eight x, thank you. And someone tell me H prime? One minus e to the x. Good, so this x turns into a 1 when we derivate it. And we go subtract. And this is e to the x. And it's just an x. It's not some complicated thing. So we don't use chain rule. We just say it doesn't change. Good. Now let me remind you that the formula for quotient rule is as follows. And I'm going to say it my way, but maybe you guys use P's and Q's or something. I always say low D high minus high D low all over low squared. Okay. Now that's kind of like a song to me, like low D high minus high D low all over low squared. So if that helps you, go for it, because this is the only way I've ever memorized it. Let's go ahead and plug it in, yeah? So we've got low, which is 4x squared times 1 minus e to the x. Oh, guys, I wish I had like one of those expensive writing pads. Okay, minus high times low prime, which is just 8x. I'm actually going to squeeze that guy in here. Sorry, that looks like that. Okay, and then all over low squared, which is going to be 64x squared. Oh, no. Sorry, guys. I just did low prime squared. So that's actually going to be 16x to the fourth. All right. Now from here, we would simplify. I don't think professors always want you to, so that might depend on your professor. I'm not sure. But let's go through and do it just in case. So we've got 4x squared minus 4x squared e to the x. You're welcome. Goodbye. And good luck on your test. E to the x minus 8x squared plus 8x e to the x. And then, yeah, we already said 16x to the fourth. From here, I see that these are like terms. So I can actually turn these into a minus 4x squared. I also see that there's a 4 in every term. So I'm going to pull a 4 out of each term. That's going to look like, oh, my bad. Negative x squared e to the x minus x squared plus 2x e to the x all over 4x to the fourth. All right. So there's that whole process. I hope it fits on one page. And I know that there's a lot of numbers and letters and terms. But remember, all we've done is we said this is high, this is low. This is H prime, this is L prime. And we plugged it into the equation. That is all we did. Okay? All right, everyone, we're out of time now. I hope this helped you, and I hope that you guys have good luck on your exam. You're welcome.